So we are starting our first lesson on surface area, and we're going to just look at prisms and cylinders today because they have very similar formulas. Now, before we talk about the formulas, remember, if you have trouble remembering what the vocabulary are or what the formulas mean, you can always go back to a net, and we're going to be doing an example of the nets and how to do surface area with that too. Okay, but we want to talk about some vocabulary before we go into what surface area is. So we already know what faces, bases, and all that stuff is, but now we have specific faces which we call lateral faces. And lateral faces are the faces that are not the bases. So you'll remember for a prism, the bases are those parallel faces. So, for example, these two pentagons, these are bases, right? So all the other, all the other parallelograms that create the prism here would be the lateral face. So, for example, right here, that's a lateral face, this rectangle. All right? So all these faces, all these shapes that connect your bases together, they're what we call lateral faces. Okay? Um, You'll notice two different shapes here. I just wanted to show you not all prisms have to look like this. This is what's called a right prism. And this is what we call an oblique prism. Alright, and the difference between the two, obviously your right prism, the faces here are rectangles, your oblique prism, your faces there are parallelograms, and that's connected to the altitude. So the altitude we're talking about with our prisms is basically the same idea as the altitude or height we talked about with area. It's the perpendicular height between the bases. So in a right prism, the bases are going to be perpendicular to your lateral face. So then this edge that connects the two bases, that distance is what we call the height. So you'll see that right angle again, super important. With your oblique prism, then our height's going to be outside, right, somewhere out here. This will be your height. Don't worry too much about oblique prisms. You want to recognize them, but they're not a big deal because we are mostly, actually, almost exclusively working with right prisms. So I just wanted to show you we do have other types of prisms, but we are going to work with right prisms. All right, then we can calculate two things about our prisms. We can calculate what's called lateral area and surface area. Lateral area, hopefully you'll see lateral like lateral face. It's the area of the lateral faces. Surface area, the area of the lateral faces plus the bases, so all the faces. Okay, so lateral area and surface area, the two big ideas we're going to be talking about today. And again, we're only going to be looking at prisms and cylinders. In the next lesson, we'll talk about pyramids and cones. All right, now before we dive into the formula, I want to remind you, we can always find surface area, lateral area using a net. All right, so for example 1, let's go ahead and just sketch out a net of this triangular prism. Now before we draw our net, you might notice something. We have a missing measurement. And remember, that's not something we want to let stop us because we can actually find it. Notice how the bases are right triangles. We spent a lot of time working with these, so remember what we can do is use your Pythagorean theorem, right? And find that missing side. So we're looking for that hypotenuse C, and C is equal 5. Remember, we don't care about the negative 5 here because it's not a acceptable measurement, so we're going to just keep that positive. So we know this is 5 inches, and let's draw our net now. Remember, more than one way to draw a net. This is the way I chose to draw mine. Make sure, again, you're labeling and you're seeing everything matches up. And once we've done that, excuse me, All we have to do is find the area of each shape. So remember, the area of each rectangle is base times height. So here 2 times 4 is 8 square inches. 5 times 2 gives me 10. 3 times 2 gives me 6. We're going to look at two triangles. Area is 1/2 base times height there. And here our base and height need to be perpendicular. So base is 3, height is 4. So 1/2 of 3 times 4 is just going to give me 6. So I have 6 on top and 6 on the bottom. And this is basically, this net is just one big composite figure. So my surface area is going to be all those red numbers put together. So I add them all up, right? 6 plus 10 plus 8 plus 6 plus 6 should give me 36. And area, so square inches. So we can always use our net. If I only wanted lateral area, then I would just add those rectangles because I don't want the two triangular bases. Okay? Now, of course, you'll say, Ms. Huang, do I have to draw a net every time? It's so tedious. What if I get it wrong? What if I label it wrong? Well, then the good news for you, who thinks that way, is no, you don't have to because we have formulas. And the formula for lateral area is perimeter times height. All right, so again, lateral area, capital L, equals perimeter times height. Here's what's really important. The definition of perimeter isn't perimeter of anything, it's the perimeter of the base, okay? H for height isn't height of one of the faces, it's the height of the prism, which is that distance between the bases. Okay? Lateral area is important because you need to find surface area. Surface area is capital S, and that's just lateral area plus the area of the two bases. So that's 2 times capital B, right? So L is lateral area, and B is the area of one base. And really, that's what we did with the net. So I had the two 6s for the triangles. That's the 2B, right? Perimeter times height. You'll see the perimeter is actually what makes up the entire length of this really long rectangle. And then the height is the distance between the two. So we come up with these formulas from your nets, okay? So let's use these formulas to check if our surface area 36 square inches was correct, right? So I'm just going to go ahead and write this in again. This was 5. That was my hypotenuse we found earlier. And I'm writing my formulas, so just like we did with area last chapter, you want to write your formulas down. And then let's go ahead and calculate what we know. So I want you to find lateral area and surface area. So I'm going to go ahead and find L first. We need to find perimeter of the base. So perimeter of the base is 3 plus 4 plus 5, because the base is one triangle, right? This is the base. So then that's going to give me 12. So that's going to be 12 times. And then the height, remember the height's the distance between the two bases. So that perpendicular distance is 2, and that's supposed to be an equal sign. All right? So height is equal to 2 inches. So plugging that in, my lateral area is 24. Okay? And see, this is actually working out because if I just add 6 plus 10 plus 8, that's also 24. So you'll see they both are the same. It's again area, so I'm going to use square units. Now that I have lateral area, I can now find surface area. So that's just 24 plus, I want to find the area of my base. And like we said earlier, the base is those right triangles. So that's going to be 1/2 of the base and height of your triangle. And remember, like we said before, right angles are key. So base, height of my base shape. So I'm going to get 1/2 of 3 times 4, which is once again 6. So 24 plus 2 times 6. And that is definitely 36 square inches. Okay? So, formula obviously shorter, but if you don't remember what P, H, L, and B stand for, formula's not going to get you anywhere. Um, net, maybe a little longer, but always works as long as you draw the net correctly and label the sides correctly. So they both have pros and cons. Okay? So that's prism. Let's finish off with cylinders. Okay, just like with our prisms, because they're very similar shapes, right? They've got parallel bases and all that. We've got a right cylinder and an oblique cylinder. It's nice to know the oblique cylinder and what it looks like, but remember again, our focus is on right shapes, right polyhedrons. Just like with our prisms, we've got our parallel circular bases. And again, the distance between the two bases, this is going to be your height of the cylinder, okay? Um, and the lateral face in this case is going to be that plane connecting the two uh, circles together. If you remember how we drew that net, this whole lateral face, that's that rectangle. Okay? Now let's jump into finding our surface area using a net here. So let's go ahead and look at the directions, right? We have a radius of 4, and the height here is the height of the cylinder. That's going to be 6. Now let's draw our net and find our surface area. Alright, so this is the way I drew my net, and hopefully you're seeing super easy. I've got a rectangle, which is base times height, and I've got two circles, which is pi r squared. Radius is 4, so, this is just pi times 4 squared, so that's going to be 16 pi, which I can put in the calculator later. And the question here is, how do I find my area of the rectangle? The height's 6, but what's the base? Well, think about it. If this entire thing needs to wrap around the circle, what is it called when we're talking about the distance that wraps around the circle? Yeah, that's circumference. So the base is the circumference of the circle. So my base is 2 pi times 4, right? And then the height is 6. So the area of the lateral face is 8 pi times 6, which is 48 pi. So my total surface area is 16 pi plus 48 pi, which is equal to 80 pi square inches. And then you can put that into the calculator if I'm asking around it, or if I want you to leave in terms of pi, this is in terms of pi. Okay? Just like before, we do have formulas. Let me give you the lateral area formula and surface area formula. And it's basically what we just calculated, right? 2 pi r(h) circumference times the height, and the height, again, is the height of the cylinder. Surface area is just the lateral area plus 2 times the area of the bases, which, again, 2 pi r(h) plus 2 pi r squared. Okay? Let's just finish this off by checking with our formulas. And again, you can pick the nets or the formulas. Don't do both. All right? And let's just double check. Do we get 48 as our lateral area and 80 as our surface area? So that's the information from above. I'm just going to plug in R and plug in H. And there we go. It checks out perfectly because, again, these formulas we can pull from our net. So they give us the same answer. All right, we're going to practice this in class. Please let me know if you have any questions. Thanks for bearing with my hoarse voice.